Sampling. Learning intention. I can understand what makes a sample fair and representative. I can understand how random sampling is used to reduce bias. Success criteria. I can explain why a sample may be biased or unrepresentative. I can identify examples of selection bias in real-life situations. I can describe different methods of choosing a random sample. I can explain why random sampling is fairer than biased sampling. Sampling. If you are asked to investigate the claim that 14-year-old boys are taller than 14-year-old girls in Ireland, do you measure the heights of all 14-year-olds in Ireland and compare the results for boys and girls? This could be an enormous task, as there are about 60,000 14-year-olds in this country. In this study, we use the word population to describe all the 14-year-old boys and girls in Ireland. In statistics, a population is everything or everybody that could possibly be involved in a particular investigation or study. When a population is too large for a study, we collect data or information from some of the population only. In statistics, this group is called a sample. The purpose of a sample is to collect data from some of the population and use it to draw conclusions about the whole population. The size of the sample is important. If the sample is too small, the results may not be very reliable. If the sample is too large, the data may take a long time to collect and analyze. Bias. The sample you select for your study is very important. If the sample is not properly selected, the results may be biased. If bias exists, the results will be distorted and so will not be representative of the population as a whole. Bias in a sample may arise from any of the following. Choosing a sample which is not representative. For example, Cara is doing a survey on people's attitudes towards gambling. If she stands outside a casino and questions people as they enter or leave, the results will be biased, as these people are already involved in gambling. Not identifying the correct population. Example: the school principal wants to find out about students' attitudes to school uniforms. She questions 10 leaving certificate students only. This may lead to biased results, as the opinions of the younger students from 1st to 5th year are not included. Failure to respond to a survey. Many people do not fill in responses to questionnaires when sent through the post. Those who do respond may not be representative of the population being surveyed. Dishonest answers to questions. So we have 4 different examples of how bias in a sample may arise. So choosing a sample which is not representative, not identifying the correct population, failure to respond to a survey, and dishonest answers to questions. These are all ways that bias in a sample may arise. Example 1. Connor carries out a survey to find out if people in his town enjoy watching sport. He stands outside a football ground and surveys people's opinions as they go in to watch a match. Give 2 reasons why this is not a good sample to use. The first reason: people who go to watch football matches usually enjoy sport, hence the sample may be biased. The second reason: generally, more men than women go to watch football, so the survey could be gender biased. Random sample. One of the ways to avoid bias in a survey is to take a random sample. In a random sample, every member of the population being considered has an equal chance of being selected. Random samples need to be carefully chosen. Methods for choosing a random sample could involve giving each member of the population a number, and then selecting the numbers for the sample in one of these ways. Putting the numbers into a hat and then selecting however many you need for the sample. Using a random number table, or using a random number generator on your calculator or computer. Example 2. A football club with 80 members has 5 tickets for an international match. Describe 2 methods of choosing 5 members at random to receive these tickets. Method 1, using a calculator. Number the members from 1 to 80. Use a calculator random integer generator to generate random integers between 1 and 80. Continue generating numbers until 5 different numbers are obtained. The members corresponding to these numbers receive the tickets. Method 2, manual random selection. Write the names of all 80 members on identical pieces of paper and place them in a container. Mix thoroughly and randomly select 5 names without replacement. The selected members receive the tickets. How to generate random integers on the FX83/85 GTCW calculator. So this is the new model of the Casio scientific calculators that most schools are using in Ireland. So there is no RAN int key, like there was in the old calculators, no RAN hashtag either. So this is how we access the random number generator. So we have to use the Tools menu. So press Tools, that's the 3 dots on the right. So you press this button here, Tools. Choose Probability. Select Random. Choose Integer. For the previous example, we know there was 80 people in the club, so the minimum value would be 1 and the maximum would be 80. Press EXE, which is down at the bottom right corner here. A random integer between 1 and 80 appears. Press EXE repeatedly to generate more numbers. Record 5 different numbers, so ignore any repeats if there are any. Example: a school has 820 students and an investigation concerning the school uniform is being conducted. 40 students from the school are randomly selected to complete the survey on their school uniform. In this situation, what is the population size and what is the size of the sample? The population is the whole school. Hence, the population size is 820. And what is the size of the sample? The sample size is 40, because 40 students were randomly selected. Example: Amy wants to find out how often people play sport. She went to a local sports shop and questioned the people she met. Explain why the sample is likely to be biased. She only asks people in a sports shop. These are far more likely than the general population to play sports. So these are the reasons why the sample is likely to be biased. So this word biased comes up a lot in statistics for Junior Cert and Leaving Cert Maths. So it's important you understand what bias means and be able to identify bias.